Welcome back to our lovely channel, MotoMouths Uganda. We talk about cars, car systems, driving systems, experiences, name it. You can actually put it in the comments and we'll bring it to you here. Please remember to subscribe and set the notification so that you can be alerted when we have a new video on the channel. We are going to talk about suspensions, car suspensions, which falls under chassis systems. You know, this word, we normally pronounce it as chassis around here, but the correct spelling or pronunciation is chassis. I think it's probably from a French background. They are the ones who have this habit of ignoring the last letters.
Mm.
Yes, as always, we have engineer Ivan Chibuka, who is going to take us through these things that most of us ordinary people just ignore. Just make sure the car has fuel, it has tires, and the right passengers are inside. Then we set off. We don't know about suspension, shock absorbers, nothing. All those things we just make sure the car is moving and it can stop when we want it to stop.
Yeah.
Yes.
Sometimes we even complain. And then we continue and we leave it at that.
Yeah. Yes, so please take us through this this segment.
Yes. Good afternoon, Alan, fellow MotoMouth, and all our viewers. Once again, we go straight to business. I want to share a small presentation that I've made for this, make it easier for me to discuss these systems. The presentation is going to be about suspension systems. Alan, you can let me know when you can see it.
Yes, I can see it.
Yes. Automotive suspension systems. So what are these? What do they do? Their function is to cushion the car, its passengers, and the load it's carrying from road surface irregularities. It resists the effects of steering, braking, and acceleration so that they are not so hard on the passengers and the driver and whatever equipment or goods they have on the vehicle. So these systems also help to keep tires in contact with the road at all times. Remember, every time the tire, for some reason, goes into the air and it's not in contact with the road, you have lost traction. You can go any direction the winds take you now. So the aim is to keep, even if the road is very regular, is to keep, in fact, this is the primary role of the suspension system, or at least the springs, as we shall see later, to keep the tire surface in contact with the road, whether the road is smooth or rough or bumpy. And then these systems work in conjunction with the tires and seat springs to give an acceptable ride at all speeds. Like I said, when you start complaining about the quality of the ride, most times it has both to do with the road and the poor suspension system. If there's nothing you can do about the road as a vehicle owner or driver, there is a lot you can do about the health of your suspension system. So here is a typical, an example of a typical suspension system in a modern car. You are going to have, I don't know if you can see my cursor, but this is a front suspension system underneath the engine and the gearbox. So these parts here, these are the brakes, but these components here in black, including this strut here with the spring, part of the front suspension, and in the back, you have the axle. This is the axle, but either side you are seeing components of the suspension system. Of course, there are other obvious things like the exhaust system, gear lever here, the spare tire, the four wheels that are driving the vehicle, the fuel tank. But this image is mostly to show you some components. Most times when you look at the car in its complete form, the suspension system, most of its components are not visible to the eye. From outside and inside, definitely inside the vehicle, you cannot see anything. Even from outside the vehicle, unless you are underneath the vehicle and you are examining it, you will not see much of the suspension system. Yeah, so this drawing, of course, is a cutaway. They've removed most of the vehicle, the body of the vehicle, to show you some of these components, to bring them for you to perceive them better. Now, suspension system layouts. There are few, but in older vehicles, there was something called the beam axle, which was used to support two-step axles. Beam axles are rarely used now, although many commercial vehicles use them because they are stronger and they provide a more constant ground clearance. Independent front suspension is now more common, and it offers improved quality, ride quality and vehicle handling. The main advantages are when one wheel is lifted or drops, it does not affect the opposite wheel on the same axle. So one wheel can go into a pothole and the other will just stay level. Basically, the vehicle will try to stay level so you will not feel those inclines that much, or even in this lateral direction. And then you have the unsprung mass being lower. The unsprung mass is the suspension system divides the vehicle, the mass of the vehicle, into two parts. The sprung mass is everything that is carried by the spring, by the shock absorbers and the spring, the strut, everything that is protected from the rough road. And that is the biggest chunk. The unsprung mass is everything below, like the tire, the brake system, everything that suffers more, the rougher the surface of the road becomes. So the unsprung mass is that part which is not, you'd say that part which is not protected by the suspension system. The sprung mass is the one which is protected from the rough road by the suspension system. I hope that is understood. So the unsprung mass is lower. In other words, the mass, the weight of the vehicle that is not supported by the springs is lower. Now, this allows the road wheel to move, the tires to move faster because they are not, they are kind of, I don't want to use the word shielded, but it allows them to move faster with corrugations in the road. So when there is a dip, the tire goes faster because it is lighter. So I don't know if I've made a good description of that, but this is advantageous in that when the unsprung mass is lower, the comfort of the vehicle is higher because a smaller mass is protecting a bigger mass, which is where you are sitting, and it is protecting it faster. The effect of the protection comes faster. So if you are sitting in the vehicle, you may not even feel some of the smallest corrugation, which you would feel, for example, if you are riding a bicycle that does not have suspension. So it reduces on problems with the changing steering geometry. Steering geometry is, for example, when you turn, remember when the wheels turn, one wheel is going to travel a longer distance than the other. And sometimes if this is not designed properly, you do have one side of one wheel, especially the one which is traveling the shorter distance, you'd have it scratching the road because the other wheel is moving a longer distance. This one is not, but they are held together by the same axle. So that creates a lot of tear and wear, but these suspension systems reduce on that. And there is more space for the engine at the front because they are independent. So they're independent suspension systems. So you have, if it is a front axle, you have the independent system on the left. On the right is independent from the one on the left. So in the middle, you can have empty space where you can put your engine and gearbox or whatever. For rear engine vehicles, you'd have your storage in there, but at least it allows the vehicle height to be reduced. The shorter vehicles have the advantage of being more comfortable and stable on high roads, especially at higher speed. Yeah, so it's advantageous to have more space for the engine at the front. And softer springing with larger wheel movement is possible. Again, because the system is independent and there's a smaller sprung mass, the wheels can move up and down much faster. So that larger wheel movement is what helps the comfort because it means the rest of the vehicle, the sprung weight, does not have to move with every bump. Alan, I don't know if I'm getting too technical, but I hope you have got the gist of what I'm talking about.
Yes, I'm following.
Yes. So now, here some an example of an independent front and rear suspension components. Up here, you have the shock absorber, which most of you are used to seeing, and even the springs, because sometimes those are visible when you look at the vehicle in its packed form. And then there are these other components lower. What you are seeing on the outer side here is the braking system, but below that are the suspension system components. Now you are going to see these joints here, which normally have rubber bushes and stuff. Those are the things that normally go bad. Those are the things that we regularly have to change in Uganda because of our bad roads. In other countries, people also change this, but they take longer. But here, they are a big issue because for many people who drive on bad roads, those components have to be changed so frequently. So a lot of people actually plan their expenses over the year. A lot of drivers plan their expenses over the year on how they are going to change those things. There are sometimes it also depends on your driving style, the roads you are driving on, and also what spares you are using. But otherwise, most of these other components, they can last as long as the vehicle. The shocks, most people change shocks for the duration of the time in the duration they have the vehicles for. And these things are common. It's common to change these things because again, we import used cars. So tugenda ozireeta wano nga bazimazeemu supu eri wayinza okuba tewaliyo binnya. There may not be potholes, so many potholes in the countries of origin of these vehicles. Naye era they have humps. Maybe they climb curbs. In the UK, we used to park on the street parking is common. We used to park with one wheel on the side on the pavement and one wheel in the road. It's very common to park like that, at least around London, where I used to live. So you find vehicles parked like that. When you drive away, it comes back to be level. So every time it is flexing, every time you are parking, you may not have a lot of potholes, but you are stressing the suspension system when you do that. You are not stressing it so much, but over the years, these components, components that have rubber bushes, yeah, they get tired. And also the edge, just the edge. Even if you park a vehicle, rubber naturally reacts with some components of the air and it gets old and cracks. So they need to be changed anyway, just because of age. Yeah, but in Uganda, we change them a lot. I'm dwelling on this because this is where most viewers concerns are, because these are the highest costs for them. Shock absorbers and those bushes. For those components which flex a bit. There are components in the suspension system which flex to give you that comfort. So they have rubber components, and that rubber tends to give way after some years of usage. But here in Uganda, we suffer a lot because of the bad road, but also because of our poor driving style. I have people who drive and they say, "Anze bwentuuka mu binnya sikendeeza speed, shocks zibimalanga." You know, when they get to a bad road, they just drive anyhow, saying, after all, they spent money on the new shock absorbers, let the shock absorbers pay for themselves. Something like that. Okay, pay for. Basically, they are getting value for money as far as they are concerned. But if you are buying a set of shock absorbers every year, well, you are spending more just because of your driving style. I can tell you, I've driven a vehicle from brand new, I think, to until I handed it over to someone else when it had about 290,000 kilometers. The suspension system had not changed. At least the shocks and the spring, they have not been changed. Yeah, so depending on your driving style, some components can really last long. Yeah, but of course, there are other factors. Like we said, we have bad roads here and then the age of the vehicle or the components. So springs, many of us know what a spring looks like. The requirement for springs are as follows. They should be able to absorb road shocks from uneven surfaces, and they should also control ground clearance and ride height even when you load the vehicle. Of course, it's going to, because of the independent suspension system, most vehicles will kind of lower. The ride height will become shorter. And then they also should ensure good tire adhesion, again, because they push the wheel to the ground all the time, so that even if you hit a pothole, the spring pushes the wheel to the bottom. That way, the sprung mass does not have to follow the wheel into the pothole. And they also ensure support for the weight of the vehicle. So a spring should be able to support the entire weight of the vehicle, even when loaded, and transmit gravity forces to the wheels and nowhere else. Because if the gravity forces are not transmitted to the wheels, it means the unsprung mass is going to follow. It's just going to follow the corrugations in the road. If there is a pothole, the sprung mass is also going to follow. And we don't want that, because at the end of it, after 2 kilometers, if that keeps happening on a bad road, you would want to stop because you feel like throwing up, like being on a boat in bad weather. Yeah, so dampers, which are the shock absorbers, their role is to ensure directional stability. They also ensure good contact between the tires and the road in conjunction with the springs, and they prevent buildup of vertical movements. Remember, the springs cause the vertical movements when there is a depression in the road, but they should not go far. So the vehicle should not go far. When the spring does that sudden pushing of the tire, it should kind of again be controlled. Because when you don't have shock absorbers, but you have good springs, when you hit a pothole, the vehicle will keep doing what I'm doing. It will keep bobbing up and down continuously. But the shock absorbers, kind of, the moment you go into the pothole, the spring do their job, then the shock absorbers come in and stop that oscillation thing. In fact, one way of testing to see if your shock absorbers have gone bad is to go either to the front of the vehicle or the rear of the vehicle, depending on what shock absorbers you are testing. Push the vehicle up and down several times and then release it. If the vehicle keeps bouncing for 1 or 2 seconds, you don't have good shock absorbers. So it's your springs that are doing all that, but you are like you are on a roller coaster. So that is one test for bad shock absorbers. We are not going to talk about springs. Normally, springs they break. I've seen them break, but usually it takes a lot to break it. You'd have to have done something grave, like maybe drive over a ditch or something very terrible to break a spring. Some people change their springs to make the car go higher or gain a higher posture. I don't think it's a good idea. The manufacturers of the vehicle have very good reasons why they have put a certain size of spring on your vehicle. So when you alter that, you are altering the stability of your car. You are giving up. You may think the vehicle is gaining height, but you are losing stability, and that can become dangerous while you're on the road. And you may never find out until it is too late. So dampers also reduce wear on tires and other chassis components. You said we call it chassis, not chassis.
Yes.
Yeah. So this is an example of a twin tube gas damper design. There are some dampers which use liquids, fluids like oil. Some use gas, some use a combination of gas. Some like this one use a combination of oil and gas. Essentially, a shock absorber is like your bicycle tire pump, but it is more complex inside. Basically, it absorbs shock by compressing air or oil or whatever liquid they've put in there to do its job. But eventually, they wear out, the seals wear out, and the gas leaks, or the whatever fluid they put in there leaks, and then they lose that damping ability. So that's why you need to change them. That's why if you drive roughly, you go on hitting potholes, you are breaking your shock absorbers. They are supposed to absorb shocks, yes, but if you notice that the road is bad, drive accordingly, drive slower. You don't have to break something simply because you bought it, simply because you own it. You know, you may have the money to buy new shock absorbers, but the world is losing more raw materials in trying to make more shock absorbers for you to consume. So we don't always have to consume everything just because we have access to it. That's being greedy. So if you're on a bad road, just drive slower. You save more money. You drive safer, and everybody will be happier. Normally, rough roads with the potholes are usually maram roads with dust. So if you drive slower, the people living next to the road will appreciate you for not dousing them in dust. And we call it makeup. They give copper girl. Yeah, so it helps so that you don't leave people, you know, somebody may not even be home when you pass by, but you passing by their house at such a terrible speed and raising dust means they come back to a very dusty bed in the evening. Yeah, sorry, I'm kind of diverting, but that is my presentation. I don't know if you have any comments or questions.
Thank you very much for taking us through some of these components that we usually don't see. Suspension systems, the shock absorbers, the springs, brakes, all those things underneath. Earlier, when we were talking about SUVs, you talked about specialized suspensions. I have seen some videos of SUVs, especially in Australia, those countries where they do a lot of off-road, Australia, South Africa, where when someone buys the car, maybe it could be like a Land Cruiser LC79, then they go to some specialized garage and buy specialized suspensions and
I have someone right now looking for such systems for a Land Cruiser hardtop. I think it's a 2017 model.
Yes,
So,
and then they
yeah.
there,
Mm.
and sometimes you see even under the car, those components tend to even have a different color. Yes?
Like
When-
yellow, like Monroe shock absorbers, they are usually yellow. Is
Mm.
it Monroe or Monroe? How do you pronounce that?
I think it's Monroe. Yeah.
Uh-huh.
So yeah, some of those ones are also common on such cars that have to take on a lot of a lot of work. I wanted you to point out to explain something. You see these off-road cars again.
Mm.
Uh, Sometimes there's a time I asked a driver a question, but I think either he didn't explain it so well or it is me who didn't understand. You
Mm.
have cars that have tires that are big.
Mm.
uh, Land Cruisers, for example, the LC 200, 300. But
The
then
the
when
tire
you
is big already, that like the normal standard tire that came with it, or they have retrofitted.
no, not retrofitted, I'm just talking about the tire that is big.
That is already like designed for that vehicle. It is that size. It is a big
Yes,
size, yes.
wide.
Mm.
Yes. Then I noticed that many of the cars that NGOs have
Mm.
that are working up country, they tend
Mm.
to be smaller tires. The ones you find on those Land Cruiser 79 series, the
Yes,
hard top, whatever.
yes.
So I asked this guy whether
Mm.
it is more comfortable to have the big tire or the small tire.
Mm.
Uh, I think he probably didn't give me a robust explanation on the difference in comfort.
Mm.
And also, maybe you could help our viewers on this thing where someone has to reduce the tire pressure when
Mm.
they are on some of those roads where the road surface is not so firm, like a bit sandy, bit, you know,
Mm.
and the pressure needs to be reduced to make the driving experience better. The
Okay.
last thing you comment on
Mm.
is it is common with our small cars when you are turning to leave the event and the car starts embarrassing you,
Mm.
starts making some funny noises, and then someone says, "Ha, obukono nga buweddeko."
Oh, okay. Yeah, I hope I'll
Yes,
remember. Let me try to answer them in the order you've asked them.
yes.
Okay, let me first get the Bukono thing out of the way. Bukono is not
Mm.
part of the Bukonos are not part of the suspension system. That is the drive. Those are driving shafts that are doing that. They are worn. Bukono, it's like the driving shafts for front wheel vehicles. They come out of the transfer case going to the wheel. So because they are, of course, they sit next to the suspension system on front wheel drive vehicles. Um, and the bearings inside, there's a special type of bearing in that on the wheel side that gets worn out, especially when you pass through floods, because the water enters under the boots and gets to the grease, and the grease becomes tired. So the metallic components of those bearings crash against each other and they wear out. So if possible, avoid driving through floods. And also make sure always that your boots are sealed correctly, because you seal them both ends, because there is a shaft going through them, so you seal this side and that side. So when they open up, even if you don't drive through a lot of floods, but you are going through very dusty roads, the dust gets in there, drives the grease out. Again, you run into the same problem. So that is a drivetrain system. The Bukonos are drivetrain system, part of the drivetrain system, uh, not suspension system. Now, about the tires, you are saying you have seen like some of the Land Cruisers, especially the hard tops for NGOs and what, they have smaller wheels, like the Red Cross. Those are the standard wheels that these vehicles get from the factory. They are meant for to get for a more comfortable ride on the highway, because the vehicle is able to sit at a lower, the vehicle profile is lower, the height is lower. So the stability is better. If you are going to go off-road, it is better, especially in places where you are going to encounter rocks, ditches, and what. It is better to improve the ground clearance by installing bigger tires. Again, within limit. You can find out which bigger tires you can fit. So the main difference, those bigger tires tend to be more comfortable because a bigger tire bounces a bit more. So when it comes to comfort in rough conditions, I think the bigger tires are more comfortable. They give you a better ride quality than the smaller tires. But the smaller tires also serve the advantage, especially if the car is going to be driven a lot on the highway. And those vehicles, yes, they do some off-road driving, but most of the time they are on the road. The difference though is that it may be driving to Yumbe, for example, to a camp in Yumbe, if there is a camp. Most of the driving, the first about 700 kilometers will be on the tarmac. The last 50 kilometers may be on Maram, but it will still be a road. It will not be off-road. So those tires are still good enough. They will serve the purpose. It's okay because that's the tire size that the manufacturer has fitted. Usually what you see the manufacturer has fitted is best for that vehicle. But in case you are really going to go off-road, like in the national park and all that, or you are frequently driving on very muddy roads with the deep ditches, then it is better to get fatter tires. But then again, don't put very fat tires, because a fatter tire, when the suspension begins moving the tire up and down to make you comfortable inside the vehicle, the tire is going to touch the body very easily if it is too fat. And also when you turn, the tire is going to touch the body of the vehicle very easily if the tire is too fat. Because when you try to steer extremes left or right, the normal tire which came from the factory would never do that, because the manufacturer calculated the size of the tire not to be able to touch the vehicle. You put a big fat tire, that changes. And also the sounds the vehicle makes when you change tires also changes. You may hear more road noise, especially on the highways, when you have those wheels which are used in very, very muddy terrain, on sandy terrain. On the tarmac, those things make a lot of noise. So if you're not used to them, you can even get worried that there's something wrong with the vehicle the first time you use them. Now, regarding deflating tires in sandy places, it's not something we do here often, because again, we don't do a lot of off-road driving. But I've been to the Middle East and gone on those, they call them desert safaris. And they first drive, they come pick you from the hotel, you drive, and the SUV, the settings are normal. But as you are going away from the tarmac and you are now getting into the desert proper, they stop and deflate the tires, you go into the desert, do your thing. When you come back, they line up again, many vehicles. You find them lining up to refill the pressure to what it's supposed to be on the highway. What happens is when you deflate the tire, the surface that is touching the road becomes bigger. So because when you go into a muddy off-road environment or a sandy off-road environment, you are going to lose traction. So when you increase the surface area for the area of the surface area of the tire that is in contact with the ground, when you increase it, you are improving traction. The traction that you have lost because of the loose surface that you are now driving on, you regain some of it by deflating the tire. But then again, you should not be driving very fast, because these tires are flexing. That rubber is flexing because a portion of it at the bottom is flat. That rubber keeps flexing every time the wheel turns and the surface comes in contact. The tire comes in contact with the surface you are driving on. So the tire can heat up easily because the tire is expanding and is flexing too much. So if you drive at high speed, the tire may get too hot. So usually, because you are driving off-road, you drive slower. I never saw those guys driving higher than maybe 30, 40 kilometers when we were in the desert. Of course, they took us to the sand dunes and all that. They do some, but I noticed it's not totally off-road. They kind of seem to have tracks. Maybe you find overnight the wind blew the sand back onto those tracks, but they usually follow certain tracks. So the sand there is kind of compacted in those areas where they are driving. They know, you may not see the road, but they know where they should be passing. I'm sure you'd sweat a little bit more if you really went off the tracks that they normally use. So I'm not sure we even experience proper of Sunday road driving. Okay, Sunday surface driving. Yeah, but the point is deflating the tire increases the surface area of the tire that is in contact with the road surface. You recover some of the traction that you've lost. I hope I've tried to give you a good answer to your questions.
Yes, you have.
Yeah, we have run out of time. I think we have less than a minute to go. I thank you very much for hosting me again to talk about suspension systems.
Thank you too. And as always, we urge our viewers to subscribe to get more of this amazing content about driving and car systems.
Okay, thank you very much and have a good afternoon.